This lecture is about the anatomy of the cardiovascular system. I'm going to be using the PowerPoint presentation identified as Anatomy of the Heart, which can be found on Canvas under Chapter 20. You might want to have this in front of you as we go through this. So what is the cardiovascular system? Well, it's an organ system that consists of the heart and blood vessels, and it's a closed system. Closed means that it doesn't open to the outside of the body. Purpose of the cardiovascular system is to circulate blood throughout the body to, 1, deliver oxygen and nutrients to the tissues, two, remove carbon dioxide and wastes from the blood, and 3, deliver hormones to target cells. So where is the heart located? Most people will say it's in the left side of the thoracic cavity. But actually, if you look at this picture, you'll see that it's really right smack in the middle. It's along the midsternal line. 2/3 of the mass of the heart is in the left side of the thoracic cavity, which is why most people think the whole heart is on the left side. You'll see that the heart sits on the diaphragm. This is another view of the heart. So to be a little bit more specific, the heart is in the thoracic cavity, but the thoracic cavity is subdivided into the pleural cavities and the mediastinum. The lungs can be found in the pleural cavities. And the heart here is in the mediastinum. Within the mediastinum, it's surrounded by the pericardium. Peri is a word that means around, and cardium, of course, means the heart. So it's actually a double-layered membrane that surrounds the heart. And you can see the little white fibers here show you that the pericardium anchors the heart to the diaphragm on the bottom and to the great vessels as they leave the heart. This is a closer view of the pericardium. So I've taken a little chunk over here and expanded it. You can see the pulmonary trunk, and here you can see the pericardium. So the pericardium is a double-walled sac that surrounds the heart. The outer layer of the pericardium is called the fibrous pericardium, and you can see it right here. And that anchors the heart to the pulmonary trunk. Then you can see the inner layer is called the Seraphs Pericardium. And that's right under the fibrous, but then it takes a little U-turn and covers the surface of the heart. In between the two is the pericardial cavity. You can also see the myocardium, which is the wall of the heart. So if we go back again to the pericardium, we said it was a double-walled sac, and the outer layer is called the fibrous pericardium. This is made of connective tissue, which is infiltrated with fat. So if you take a look at this picture to the right, this is a sheep heart. It looks just like the sheep hearts that you're going to be dissecting. And you can see this white tissue on the outside is fat, and they've actually cut through the pericardium. So the role of the fibrous pericardium is, again, to anchor the heart to surrounding structures. And those structures are the diaphragm and the great vessels. It also prevents the heart from overfilling. And the reason that it's able to do that is because it consists of connective tissue which has a lot of collagen, which prevents the heart from expanding. The inner layer of the pericardium is called the Seraphs Pericardium. And this is made of serous tissue. So if you remember from A&P1, serous membranes are double-layered membranes found in closed ventral body cavities. Okay, so that's a review from A&P1. The type of tissue that makes up serous membranes is actually simple squamous epithelium. So it's very thin. And again, it's double layered. So if you remember that the layer that lines the cavity is called the parietal layer, and the layer that covers the organ itself is called the visceral layer. So again, the serous pericardium consists of two layers. One layer lines the cavity, and you can see it's right here. So when you dissect the heart, you'll see the shiny inner layer, which is the parietal pericardium. Then there's a clear, transparent layer that covers the heart, almost like saran wrap, and that's called the visceral layer. In between the two is the pericardial cavity, and that's filled with a fluid called serous fluid. So the purpose of serous fluid is to reduce friction between the two layers of the serous membranes. So it reduces friction between the parietal and visceral layers so that the heart can beat in a friction-free environment. Okay, so let's go back a step now and take a look at the heart again, because the heart consists of 3 walls or layers. The outer wall is called the epicardium, and it's the same as the visceral layer of the serous pericardium. I'll show you that in a minute. The tissue that makes up the epicardium is simple squamous epithelium. Okay, so this is again serous membranes. The middle wall of the heart is called the myocardium, and the myocardium is actually made of cardiac muscle tissue or cardiac muscle cells. And the role of the myocardium is to contract and pump the blood throughout the body. So as the muscle cells contract, they squeeze the heart, and this pumps the blood throughout the body. Okay, so I'm going to come back to that in a minute, but let's just take a look. Here are the 3 layers of the heart wall. So you'll see the epicardium is the outermost layer. And by the way, the word epi means above. That's a good word to know. So above the heart. It's also the same as the visceral layer of the serous pericardium. The middle layer of the heart is called the myocardium, and remember from A&P1, myo means muscle. And then the inner layer of the heart is called the endocardium. Now the myocardium, I just want to mention, the cardiac muscle cells contract with incredible force. And they actually produce probably twice as much force when your heart is at rest as the skeletal muscle cells in your leg do when you're sprinting. So think about that. The cardiac muscle cells in your heart when you're at rest still produce twice as much force as the skeletal muscle cells in your leg when you're sprinting. That's really amazing. So, coming back to the myocardium again, weaving throughout the myocardium in a crisscrossing type of pattern is connective tissue called the fibrous skeleton of the heart. And the purpose of this connective tissue, which by the way consists of a lot of collagen and elastin. Remember, collagen strengthens tissue. It's like a strong rope. elastin allows it to stretch but snap back. So the purpose of this is threefold, and it actually depends where it's found. So one place you find it is between cardiac muscle cells. And when it's found here, what it does is it anchors cardiac muscle cells. It acts as an anchor so that they have something to pull against when they contract. Another place that you find it is between the chambers of the heart. And when you find it here, its role is to insulate. And in that sense, it prevents the electrical charge or the action potential from jumping from one chamber to the other. So again, it prevents the, I'll write AP for action potential, from jumping between chambers. So it's electrically insulating the chambers of the heart. And lastly, another place you find it is at the opening of the great vessels. And what it does here is it prevents the opening of the great vessels from overstretching. And that's because as the blood exits the ventricles, it does so with great force, and it would overstretch the openings of the aorta and the pulmonary trunk if there wasn't something there to keep it tight. Now the last layer of the heart, or layer of the heart wall, is called the endocardium. This is the innermost layer, and it lines the chambers of the heart. And this is made of simple squamous epithelium. And when it's found lining the heart, again, it's called endocardium. But this simple squamous epithelium continues through the heart and into the great vessels. And as it moves into the great vessels, it's called endothelium. So again, in the great vessels, like the aorta and the pulmonary trunk, it's still simple squamous epithelium, but they call it endothelium instead of endocardium. All right, so let's look at the heart now. And if you did, you'd notice that there are 4 chambers in the heart. The 2 on top are called the atria. The 2 on the bottom are called the ventricles. And the atria, their role is to receive the blood. Well, let's start with it. Their main role is to pump the blood to the ventricles. But their other role is to receive blood returning to the heart. So if you look at the right atrium, and the word atrium is singular, it's receiving blood returning from most of the tissues of the body. And so it's got low oxygen but high CO2 because the tissues have removed a lot of the oxygen and dumped in carbon dioxide. If you look at the left atrium, it's receiving blood coming back from the lungs. And so the blood just picked up oxygen, so it has high oxygen and very low CO2 because that was just dumped. The structure of the atria are pretty much thin. So it has a very thin layer of myocardium. And the reason it has so little myocardium is it doesn't have to work that hard. It only has to pump the blood to the ventricles. It's a short distance. So if we look at this last picture here, you'll see, you can see here on the right atria. This is an anterior section, anterior view, frontal section. So right atrium, right ventricle, left ventricle. And you can see how thin the lining of the ventricles, the atria, are compared to the ventricles. You also see the pulmonary trunk that leaves the right ventricle and the superior and inferior vena cava that dump into the Oh, so we're just about done.